Uh, okay, hi. Good afternoon. Today we will discuss about resistance variation with temperature. We are from Group 7. First of all, I will give to Loges to explain what is resistance.
Okay, I will explain about what is resistance. So let me share my screen first. So what is resistance? Resistance refers to a measure of the opposition or current flow in a particular electrical circuit. It also refers to the property of materials that allow the flow of electric current, which is ohms. It represented by the Greek uppercase letter omega. Moreover, the resistance depends on the voltage across a particular resistor and the current flowing through it. So I will pass to Solahin for the next topic.
Okay, thank you, Loges. Resistance. I will talk about resistance with temperature. The resistance with temperature is the resistance change factor per degree Celsius of temperature. Resistance depends on geometry of a conductor. It also depends on temperature. Electron flowing through a conductor are impeded by atoms and molecules. More particles bounce around, the harder it is for the electrons to get by. This means the resistance will increase with temperature. When temperature increase, so the particle bounce is more higher, then it will cause the resistance resistance will become increased too. Uh, that's all for resistance with temperature. So I will pass to Paul to explain what is resistance with semiconductor, right, Paul?
So let me share my screen first.
Yes, we can hear you.
Okay. So for my part, I want to talk about resistance of temperature with semiconductor. So what is semiconductor? Semiconductor is conductive material that can change specific resistance with change in temperature. Uh, the resistance change factor per degree Celsius of temperature change is called the temperature coefficient of resistance. For positive coefficient for a material means that its resistance increase with an increase in temperature. Pure metals typically have positive temperature coefficient of resistance. Coefficient approaching zero can be obtained by allowing certain metals, but for negative coefficient for a material means that its resistance decrease with an increase in temperature. For semiconductor materials such as carbon, silicon, germanium, typically have negative temperature coefficient of resistance. So, formula that used to determine the resistance of conductor at some temperature other than what is specified in resistance table is as follow. As we can see here, we can use this formula. Okay.
Okay, now let's move on to resistant temperature with copper. I'll share my screen first. Wait, Okay. Can you guys see this?
Yes.
Have you guys ever wondered why is copper used for most electrical wiring? Okay, this is because of copper has low resistivity and an excellent conductor. Plus, copper is less oxidative than other metals. Okay, this is copper, wiring for copper. And then the next one is temperature coefficient 0.393% per degree Celsius. And if the temperature increases Even only 1 degree Celsius, the resistance will increase 0.393%. And on the side note for this topic, resistance variation with temperature is often used to determine temperature variation of any electrical machine. Example in temperature rise test of transformer, and this is the formula we use to find resistance variation with temperature. Even for copper, we still use the same formula. This one is the formula to find the resistance temperature with copper, where R is conductor resistance at temperature, and RO is the conductor or semiconductor. For this one, for my topic is copper. At temperature 20 degrees Celsius, and the T means conductor temperature in degrees Celsius, and the alpha one is temperature coefficient of resistance for conductor. And the last one, TO means reference temperature that alpha is specified at for the conductor material. That's all from me. Thank you.
Okay, can you hear me? Alright. So the conclusion is, as we know, resistance and temperature is directly proportional. When temperature is increased, then the resistance will become higher too. So the temperature will affect the resistance, but it is also depends on the material. And then, as we know, semiconductor like carbon is negative temperature, and also uh, we know that copper is the best what best material used for current flow because it's low resistivity and oxidative. That's all from us.